Hello, my name is Afika binti Amar Nizam, and we are from Group 42, and we will be presenting about BP Texas refinery explosion that happened on 2005.
In 2005, the BP Texas City refinery experienced a devastating explosion, marking one of the industrial disasters in U.S. history. The incident resulted in 15 fatalities and over 180 injuries, highlighting the critical safety failures. So, what caused this disaster? Investigations pointed to serious safety failures, mismanagement, and outdated infrastructure that had long been neglected. The immediate trigger was on overfilled raffinate splitter tower, which led to a dangerous hydrocarbon release. This gas ignited, causing a massive explosion that devastated the area. BP acquired the refinery from Amoco in 1999, but safety violation had already been a long-standing issue. Unfortunately, these concerns were not adequately addressed. Investigation by the U.S. Chemical Safety Board uncovered systemic failures, including poor safety culture, inadequate hazard assessment, and outdated emergency response protocol.
I'm sure you are not curious about what happened during the day. So, on March 23, 2005, BP attempted to restart the isomerization unit after a scheduled maintenance shutdown. So, the raffinate splitter tower, which is a key component of this unit, was overfilled due to faulty level indicators and also the high alarm was not functional. A large volume of flammable liquid was sent into the blowdown drum, which is actually designed to handle vapor but not liquid hydrocarbons. It overflow and release a dense cloud of highly flammable vapors into the surrounding atmosphere. Then at 1:20 p.m., a nearby pickup truck ignited the vapor cloud, causing a massive explosion. There were 15 fatalities and injuries to over 100 active workers, making it one of the deadliest industrial disasters in the U.S. refining sector. Next, the explosion caused extensive structural damage because the blast radius extended over several hundred meters. Moreover, BP lost over 1 billion USD in regulatory fines, production, and damages.
Hello, my name is Lois Yang and I'll be talking about the technical failures. Now, one of the major failure was the overfilling and overheating of the raffinate splitter tower. Operators ignored the high-level alarms, leading to unchecked hydrocarbon accumulation. By 3:16 a.m., the liquid level exceeded 137 feet, flooding 57 out of 70 trays. Additionally, the reboiler overheated the system at a rate of 75 degrees Fahrenheit per hour, far beyond the safe limit, causing a dangerous pressure rise from 20 psi to 63 psi. Next up, on the blowdown drum failure, the facility relied on a 1950s era blowdown drum, which is very outdated. This vented flammable hydrocarbons into the open atmosphere, instead of safer closed flare system. At 1:20 p.m., a running diesel truck ignited the vapor cloud, resulting in a massive explosion equivalent to a 3-ton TNT. Now, the disaster could have been prevented. Multiple alarms have been triggered, and yet operators ignored the high-level alarm. A backup alarm at 78% failed due to a sensor malfunction. Despite the pressure rising dangerously high, no emergency shutdown has been activated. Even worse, the emergency shutdown system was bypassed, leaving no safeguard to stopping the escalation. Now, in this case, the BP Texas City explosion is a tragic example of how human errors, poor processing, and also outdated safety infrastructure could lead to disaster. This incident highlights the critical need for stricter safety procedure, automated shutdown mechanism, and proactive hazard identification to prevent future tragedies.
Hi, my name is Fikri. So I will be explaining ethical reasons for failures. So the first one would be profit over safety. Cost cutting led to outdated equipment and deferred maintenance. And the workers ignored modern safety systems to save money and violated engineering ethics to avoid harm. And the second point would be toxic safety culture. The workers feared retaliation for reporting hazards, and the management ignored safety warnings and violated stakeholder responsibility, which included employees and community. And the third point would be engineering ethics failures. There was no hazard review for over a decade, and the engineers pressured to bypass safety upgrades and neglected risk management. And the last point is lack of accountability and transparency. BP downplayed safety violations and hid critical data, and they failed to cooperate social responsibility, and there was no proper safety oversight from executives. That's all from me.
To prevent future failures like the BP Texas City refinery explosion, we must address both ethical and technical aspects. Starting with ethical recommendations, it is crucial to foster a safety-first culture where safety is prioritized over cost-cutting. Conducting frequent safety audits and encouraging open risk reporting ensures that employees feel comfortable reporting hazards without fear. Leaders also must be held accountable for enforcing safety policies, and an anonymous reporting system should be in place to encourage transparency. Additionally, continuous training on hazard awareness and emergency response is necessary to prepare employees for potential risks. Lastly, strict compliance with OSHA and industry regulations through regular safety inspections will help maintain a secure work environment. On the technical side, implementing proactive maintenance for critical equipment can significantly reduce failures. Investing in advanced safety systems such as backup controls, improved alarm system, and automation adds extra layers of protection. Regular hazard analysis combined with real-time monitoring will improve operational reliability. Furthermore, enhancing process automation for fluid levels and pressure control ensures better system stability. Finally, conducting emergency drills will prepare employees to respond swiftly and effectively in the event of an incident. By focusing on these ethical and technical recommendations, we can create a safer workplace and prevent catastrophic failures in the future.
This disaster was entirely preventable. Engineering failures, neglected safety protocols, and BP's prioritization of cost-cutting over worker safety played a major role in the explosion. As a result, BP faced massive financial penalties, over $2.1 billion in settlements and fines. This investigation that followed forced significant improvement in safety culture and risk management across the industry. The key takeaway here is that proactive process safety management and corporate accountability are crucial. Ethical leadership and strict adherence to safety standards can prevent future tragedies like this one. Thank you.